Hello everyone. I'm starting again this C programming for college first year syllabus topics. So the next topic which I'm going to discuss today is mathematical operations. Now, how we can perform the different mathematical operations? So we basically have two ways. One is using the arithmetic operators and secondly using the C math functions. So C provides a library math.h header file, which has the library functions, math functions, which can perform different kind of operations, different functions which can give you different results, right? So we first come to the arithmetic operators. So arithmetic operators, as you all know, is the ones which we have been using for very long. So, but how we can use this in our C programming, so that I would like you to show you. So we know the operator, so there's nothing very different to tell here. So what I am coming straight to a program to illustrate what are these different operators and what are the results when we use these operators. So let's see. We take two values int a and b, and let's say a is equal to, we can initialize here only, a is equal to 5 and b is equal to 2. And now what we are going to do is, in this one, we are writing the different operations. So we can write percentage t plus percentage d is equal to percentage d, okay, which is equal to, so first percentage d is for a, second is for b, third is for a plus b, okay. So this is the for the first operation of addition. So you use the plus operator. The next one we are using for minus. So we can see what is the minus operation. Okay. Next one we are going to do for the multiplication. So multiplication is like this. Okay. Next one is for division. So our division operation is this one. Now there is another one which is mod operator, which is basically this percentage symbol. So basically it returns the remainder. So if we run this one, so you can see the different results which we will be getting. Okay. So everything is okay, but we need to put a new line character. So let's start from this one so that everything comes in next line. Okay. So this is next line, and this is also next line. Okay. So now we run it. Okay. So you can see the result here. So 5 plus 2, 5 minus 2, 5 multiplication by 2 is 10. 5 divided by 2. Now here you need to see the result is 5 divided by 2 is not 2.5 but 2. The reason is very simple, because integer divided by integer gives us the result as integer. But let's see if we keep the value here as a float. Okay. So will we get the result in decimal? So let's see, we try. No, even this operation is invalid, and is kind of a warning is given that it is an integer and you're trying to store it in a float. So the result is rather even more disastrous. It's 0. So we have to write it here again, this as t. And then if we run it, we are getting no warnings, but the result, but we are not getting the exact thing. So here is the first problem. How can we get this value result is equal to this one? But as per the C, if whenever there are two integers, so under a closure property, it is going to give us the result as integer. So the only thing which we can do it here to get the result as decimal in this decimal value. So what we can do is here, this let's see 5 and this let's see is 2.0. So in this case, this will become float. Okay. The second value, which is 2.0, and the result is also float. So if we run this one, now you see the result is still not the one which we are expecting. So why? Because A and B are still the values of 5 and 2. So what we need to do is that we have to consider this is 5 and 2. Change is not for A and B, but for the entire operation. So let's see. So you can see now this is the thing, and we know if we do not want, I want up to one decimal place, so we can write 0.1, and here also 0.1. So if we run it, we are getting 2.5. Okay, so I hope this simple illustration of the different operators are clear to you. So this is the example code. So this is the code is this one, and its output. If we go for the output, this output is here. We can copy the output, so we are getting this out. So this is what we have got it, the output from here. Now the next thing is to perform some, how to apply these operators in some different scenarios. Okay, so let's see a few very simple programs we do. First program is very simple. Write a program to accept uh, length and breadth of a rectangle and calculate the area and perimeter of the rectangle. So this is the one which we want to do. So here this mathematical operators will help us. So what we need to do is that very simply, the very first step is in printf, we can write it here. Enter L comma B, and this is the prompt. And here in scanf, we can write this percentage D or 1, and we can give here comma also if we want. Or let's see, we give just here one more percentage D. And to get the value, we write ampersand L and ampersand B to extract the value of L and B. Okay, to take the value from the user and to store it in L and B. Now, the first thing is that we need to declare these two variables, L and B, so that thing is done. And also we need the area, so int area and peri, these two variables for storing area and perimeter. And we are here considering, rather assuming all everything is in integer, so we won't have any problem in calculation. We can do it as a float, but let it, it is same in case the logic will not change. So it is L into B, and your perimeter is equal to 2 into L plus B. So here we are going to print this area is equal to percentage D, and which is equal to area. And then we have a printf perimeter is equal to again percentage D, and this time it is peri. Okay. So let's see if everything is fine. So we will get the result. So let me run it. So we give the two value 10 and 20. So 10 and 20. So let's see. We're getting the area and perimeter, and again the same issue is there. So we need to give a new line character. So let me run it again. So this time we write is 10 and 20 again, and this will you will be. So you can see it's very simple. 10 into 20 is 200, and perimeter is 60, which is length into breadth, which is 30 into 260. So this is a very straight illustration, and you need to see that in programming these symbols of 2, like in a maths, we can write 2LP, but here we need to be very explicit. Okay, so this is done. So this is the first simple example. The code is this one, and its output is the one which we have done is this is the output. Okay, so let's move to the next one. Here we are going to do a different one just to show you one other function. Write a program to input the radius of a circle, calculate the area and the perimeter of the circle. Perimeter of the circle. Okay. So how we are going to do this thing? So the very first thing is that in this case, we are going to consider the radius as a float value. So let's see, this is the radius. Now we need to take the radius from the user, enter radius, and we will write it here as scanf percentage f, and this will be ampersand radius. Now our values of the area and perimeter. So let's see double area and peri, this two variable. Now this time this are double. Now we need to do the area. So area we know is pi r square. So pi value we know is 3.14 into radius into radius. That is 1. And perimeter we know is 2 into pi, which is 3.14 into radius. Okay, so we are getting this 2. And now if we after this, the result is in float. So LF, and here also we write this also LF. Now if we want only up to 2 decimal places, so we write here 2.2 LF and here also 0.2 LF. Okay, so let's see, we accept the value. Most common value we take is 14. So for 14, we are getting this result up to 2 decimal places. This is the one. And you can see the result is 615.44 and 87.92. Now, this is the one here we have assumed the value of the pi. Okay. But there might be a scenario where we need to take the value of pi is a constant value. So in that case, how we take this constant value of a pi, not to by using the constant which is available under the math header file. So we'll write it here, hash include math.h, and the header file in this case is I think it is underscore pi. Okay, so this is one. And this also is okay. Let's see first run it in the compilation. If it gives error, no, it doesn't give the error, so that means it's okay. So we can do it for the next one also. But let's see 14, and we see the result. So area has gone quite far. Why? Because this 4 where we have written. So we just have to remove this thing. So this is pi r square, and here also this pi is a constant here. Okay. So now if we work with this one, so remember this constant value of pi is defined in the math. Okay. A header file, so we can use it. So let me run it here. And this time again, we give the 14. And you can see the result is exactly same what we have got it. If you see the result, 16.544, but it is not 44, it's 75. And it is 87.92 and 96. So this variation will be there because it is taking a bigger value of this. Okay, so the value of pi, so that is why this result is there. Okay. So now, so you can use the value of pi, which is given in the mathematical constant is given in the header file, which you can use directly. Okay. So, so output little variation you will find, but it is okay. Next thing, which is a very simple concept, is about the order of operations. Okay, that is very important because without this, sometime we will not get the required result. For example, a very simple program we are doing, write a program to the accept the value of p principal rate and time from the user, calculate the simple interest and the amount uh, and the amount accrued, whatever the final amount is there. That now, how we can do? We all know very simple interest formula. It's a very simple one. So let's see. We take here the values. So what we do it here is that we take the principal is, let's see, long principal, and rate. We can take it as a. This what we can do is that we can take everything in a double in P, R, and T. And this time we need the two things, which is the first one is the simple interest and the amount. Now we are going to ask these values from the user. So we will ask the value of P, R, and T from the user. And here we are going to take these values. First one is for principal, second one is for rate, and third one is for time. And here we are going to give this as ampersand P, ampersand R, and ampersand T. And you know the simple interest is equal to principal into rate into time divided by 100. And amount is nothing but principal plus SI. Now, if you come to here, so we can write SI is equal to, let's see here, we do not take any decimal values. So this is the SI, and the amount is equal to, this we write as simple interest, and this is the amount. Okay, so amount is this one. So we just put LF, that means there won't be any value after the decimal point, it will be rounded off, and this is the amount. So let's run it. We are already getting some this because we have given here as this is a double, but we have given here float. Okay, so what we need to do is that we need to put here LF because if we want double, it will be LF, and here I don't think there will be an error. So let's run it again. So there is a semicolon missing. So let's see, we put this thing. Now let's run again. Oh, there is one more semicolon. Okay, so let's see, we give 1,000 rupees for 10% for 2 years. Okay, so let's see what we are getting. So if we multiply this thing, okay, divided by 100, so we are getting 200, and the amount is this one. Okay, so basically it is nothing giving a problem in doing this operation, but it is better if we put a bracket here, because this will maintain this entire thing, multiplication divided by 100. In some cases, in some operation, if we do not put this bracket, we will get some not correct results. Okay, so let's see. So let's see some bigger value, 15,000, and then let's see 15% interest for 5 years. So you can see the simple interest is this much, and this amount is now 26,000. Okay, so I hope you can see the simple interest thing. So this is the simple interest part. So this is the code, and this is the output of this one is here like this. Okay, so this much is okay when we are using with this kind of operations. But sometimes we have few more operations where we need to perform certain things which require some other kind of mathematical um, functions. I see here. For example, a very simple one, write a program to accept the base and height of a right triangle, calculate the its hypotenuse. Okay. So we know it's a very simple one. Hypotenuse is equal to square root of base square plus height square. So this is the thing which we need to do. So how we can do this thing? So here we need a function called square root. Okay. So there are quite a many functions are there. So if we have to get a square root of this thing, so what we can do? Uh, Very simply, we can. So we need to find the this base and height from the user, and then we have to find the square root of this thing. So let's see what we do it here. Let's see, we write int base and height, and in printf we write enter base and height, and in scanf we will take the value of base and height, which is ampersand base and ampersand height. So we have got these two things. Now we need the another thing, which is the hypotenuse. So we write this as hypo only. So this hypo is equal to, see, we need to use square root. So there's a function called sqrt. And in this one, we will give base into base plus height into height. Okay, so this is done. Now, so we can write printf hypotenuse is equal to, as we have given is a double, so LF, and we do not want any decimal value. So this thing, uh, okay, and this will be replaced by the value of the variable I. Okay. So we know a very common right triangle, which is with the side of 5, 12, and 13. So let's see if we give 5 and 12. So are we getting 13 here? Yes, we are getting 13. So this is one example where we have done this. We have used the function of square root, which is sqrt function, which is there in the math header file. Okay. So this is the code, and this is the output, which you can see is here. Okay. There is one more function. Okay, let's see. It's a very simple one. This just for this is the, here we need to write, for example, write a program to input an integer, find its, okay, we want to find its, what we say is the cube root. Okay, so cube root, if we want to find the cube root of a number, so how we can find it? So we accept the number from here. So in now we can do, and then for the cube root, let's see, double cube. Okay, and it's not the cube multiplication of this number thrice, but the cube root. So enter number, then we can give the number here. So this will be ampersand of num. And finally, for the cube root, cube is equal to CBRT of num. And here we can write the cube root is equal to cube root of percentage D is equal to percentage LF. And this time also we are putting our dot here, that decimal after decimal value will not come. One thing I tell you, that most of the functions in the C header file, C math.h header file return the float value. So we mostly use the double for storing the result. So this is the result, and let's see here we give the number, and second one is the cube. Okay, so let's see, are we getting, so okay, let's see, the number is 343. Okay, so what is the cube root of 343? Okay, we are getting a number and we should get the cube root, but at this moment we are not getting any result. Yeah, what seems maybe it's not able to, it's not given any error, but let's see, cube root is CBRT percentage. Okay, everything is fine. Okay, let me try it again. Okay, printf percentage t ampersand num. Okay, cube is equal to CBRT of num, and cube root of percentage d, which is num, and equal to percentage dot lf, which is the cube. Okay, so let me run it here one more time. So cube root of a number, let's see, very simple, is the number is 27. So 27 cube root should be 3. But unfortunately, we are not getting the result here. So let me write any other thing like 27 again. Yes, now it is given, but why is this strange thing is happening? Enter the number we have given here, the number here, enter number num, and scanf percentage this, and then it is, oh, I think the space is the culprit. Okay, see, these are the minor things which we have to take care in programming. So let's see, I think now this error won't be there. So we write here 27, so we'll be getting 3. Okay, so you will be facing this kind of issue. So let me run one more time. 343, and this time it is cube root of 7. So I hope now you understood how to find the cube root of a number. Okay, so the code is this much and its output is this much. Okay, so we have got this thing. Now, next is another one more function which we are going to use is the power function. Write a program to input principal P, R, and T. We calculate the compound interest and the final amount. Okay, so how we can do this thing? Let's go straight here. So this time again, we are going to take everything in double, that is P, R, T. And we are going to take this value of compound interest and amount here. Okay. Then we are going to ask from the user to enter the P, R, and T value. Okay, and here this time we have to give the double value LF, and then percentage LF for the second one and percentage LF for the third one. And it will be ampersand P, ampersand R, and ampersand T. Now, those who know the formula, they can easily relate with it. And those who know, okay, you can check this formula is amount is equal to principal into, now it is basically 1 plus r by 100 divided to the power of t. So basically, how to use this thing? For that, we use the function, mathematical function, math function, which take the first value. This is the first x to the power of y. So here x is 1 plus r by 100, and y, the second parameter power function which is taking, is the t. Okay, so this is the amount we are getting, and compound interest is amount minus principal. So we can write it here. The compound interest is equal to percentage point LF. Okay, so this is the CI, and let me copy it and do, and my amount is equal to percentage LF, and this time we will write AMT. Okay. So this is the amount in principle. So let's see if everything is okay, it will give the result. So let's say for 10,000 rupees for 15% for 5 years, what will be the, so almost everything has come correct, but the thing is that we need some new line characters to get the result in the next line. Okay, so 10,000 for 15, and this is the interest we're getting. So let me run it again. So to verify for first year, let's see, we give 10,000 at the rate of what we do is the 10% for 2 years. Okay, so what we are going to get it here. So it is 210. So we can very easily verify it is more than what is the simple interest. So it is the correct result. So this is how we can use the POW function. Okay, so this is the code, and its output is here. This is the value of the output. Okay, so we have got this one. Now the next mathematical function which we are going to use is there are two functions. One is we call is the ceil function. Ceiling function is basically to give you the result. It will be rounding up function and rounding down function. So these two functions we are going to use now. So uh, write a program to input an integer, and a floating number or a real number. Right, find its round up and round down value. Round down value. So if we take, for example, just to explain you a little bit, if it is 13.5, so its round up value will be 13, and round down value will be is equal to 13. Okay, so we can achieve, it's very simple. We can just take the number from the user here like this. Now this is the number, and now what we are going to do is that we are very simply mm, uh, first we need to take this value from the user, enter number. So we will write here scan f, and we can write here, okay, let this be a float only, double. Let's see, this is float, and we do it here percentage f, which is ampersand num, and here we write the round up value, which is again percentage f. Let's see what comes here. This side, the percentage round up value will be this one, and for round down value, value, this value will be equal to percentage f again, but this time the function will be float, floor of num. Okay, so let's run it. I was in bit of hurry, so okay, so chances are there. So 13.5, and let's see what we are getting. So we are getting this two values. So can we put this thing in in integer? Let's see. We try it with this thing. No, it is basically the float function is returning a double value. So we do not have a um, option here. So what we need to do is that if we want to uh, suppress those decimal uh, after zeros, so we can write is dot f, and similarly here also we can write dot f, and let's run it again, like 13.5, so it will be 14 and 13. Okay, so we have achieved our objective here. So this is the code and this is the output. So I hope you have understood what is the floor value and the ceiling value. So floor will, it is very simple, like 13.5 comes between two integers, 13 and 14. So if we do the round up, it is taking the next integer, which is 14. And if we do the round down, it will be taking the next value, which is 13. Okay. So those who are studying math, they know aware of this mathematical functions. Okay. Uh, Next thing which we are going to do is the obviously, people have done lots of trigonometry. So we are writing very simply, we are doing writing a program to accept an angle uh, in degree from the user. Okay. So, and find the sine, cos, and tan value of the angle. Okay. So we have to find, for example, very simple sine 30 degree, if the angle is 30 degree, cos 30 degree, and all this. But one thing which we need to know is that this angles take the values in radians. Okay. And we know a very simple maths is 180 degree is equal to, we call pi radian. Okay. Pi radians. So we obviously, if we want any angle is given, so we can do it by pi into angle divided by 180 will give us the in the value in radians. Okay, so that is the strategy we are going to use it. So how we can do it? It's very simple. Let's see. We will take this time again. A float is the angle, and now what we are going to do is that we have to accept the enter the angle, enter angle. Then we get the value of angle from the user. Then one more we need it here is in radians. Okay, so I'm writing it rad only. So here the float rad is equal to, okay, so pi value will take from this mathematical constant and pi multiplied by the angle divided by the value of 180. Okay, so angle is a float, so we'll get the result. Now we need to find what is the sine value. So sine of this angle. So we write here percentage f, okay, point not to any decimal value, okay, is equal to, this time we write percentage at least up to two decimal places to f of the, now here we will write the sine of the radian. No, here is the angle. Here we write sine of the radian, so that will give this angle. So we are getting the sine angle. Now let's see the next one. This one is for the cos. We will write the cos here, and this will give you the cos angle. And the last one is the 10. Okay, so 10, and we here also will write the 10. Again, we might face the same issue, so which we faced earlier. So putting in the next line, we write new line character. So let me run it. So let's see, the angle is 30 degree, and we know it's sine 30 degrees 0.5, 0.87, 0.58. It is quite near to the answer as per my knowledge. So we can take this one. So we have done this part also here. So our output is yes, so we can take the output. Now, finally, we try to do one more last function, which is the log and exponential function. The you people must have known that you can use the long function logs to perform the mathematic addition and multiplication and division. We are doing write a program to accept two integers and find their product without uh, using multiplication operator. So how we can do this thing? Okay, a bit tricky, but here we have the multiplication operator. So let's see, we come to here. What we have to do is that, let's see, we take the two number here in a comma b, and we write here printf, enter value of a and b, and then we write scanf percentage d, some space percentage d, ampersand a, ampersand b. Okay. Now what we do is that we need to do something. Okay, I think most of the function has take. So integer, okay, let's see, we take a double of c and d. Now what is this? I tell you, c value will be log of a plus log of b. So basically, when we add two log values, basically we are doing to get the multiplication. And once we get the log value, then we have to find the anti-log. So anti-log we can get by the function exp of c. So here we see what is the result. Are we getting the same result? So printf, and we can write, which is percentage d into percentage multiplied by percentage d is equal to percentage dot lf. So here we are getting a comma b comma d. So are we getting the result here? So let me take the value 10 and 20. So you see it's 200. It's not, and you can take any other number. Let's say 15 and 5. So this is 375, and I don't doubt the computer. It's okay. So this is the code, and this is the output. So you have seen I have tried to use all the mathematical functions which are there in this, and how to use them. You can easily see with the examples which I have used. I think you can get it. So this session has covered all the operators, mathematical operators, especially the arithmetic operators and the mathematical functions which are there in your syllabus. Okay, so here we come to the end of this session. As usual, I'm asking again you to, if it's giving you benefit, please share my videos, subscribe them, okay, so that it will motivate me to do more videos on these topics. And my objective is to cover all the topics of first year engineering syllabus, so that students who are studying in the first year having no programming background will find this all videos very helpful. Okay, thank you very much, and see you again in the next video.